We are going to talk about slope today. So slope equals the steepness of the graph. Steepness of a line. Which in math, when we look at a graph, we can count rise and then put it over the run. Rise over run. So we're going to watch a super duper boring video, but it's not very long. Slope Dude. He's my friend. So let me show you Slope Dude.
Welcome to the adventure of Slope Dude. Meet Slope Dude. He loves to ski. We are going to follow him and he'll teach us some important aspects of slope. This is the course he's skiing today. Again, what he says will teach us about slope. You need to remember that Slope Dude always skis toward the right or eastward. When he starts out, he's going uphill. It's hard work. He says puff, puff, positive as he goes up the mountainside. Puff, puff, positive. Puff, puff, positive. Puff, puff, positive. Now he's at the top. It was puff, puff, positive all the way up the mountain. But now he can look forward to the downhill. On the way down the mountain, he says, nice, negative. Nice, negative. And now, after the downhill, he's in for the hardest part of the ski run, the long, flat part. He says, this is zero fun. This is zero fun. This is zero fun. This is zero fun. And as he finishes the flat part, he doesn't see well ahead, and all of a sudden, he comes to the edge of a cliff. It's straight down. So frightened is he that he says the worst curse word possible in math and in algebra. Undefined. This has been the adventure of Slope Dude. Remember always what he said during his ski trip.
Okay. Pretty boring video, right? I love it though. It's one of my favorites. I know.
No, actually, he's undefined.
Okay, so let's look at our foldable and let's add to it. So whenever he's going uphill,
up the hill or up the slope,
says
he
puff,
said
puff,
positive. On his downhill run, he
okay, so go ahead and write puff, puff, positive. So the slope is positive if it's going uphill when we look at it from left to right. So he's having to huff and puff to get up that hill.
He said nice, negative.
Then he gets to go down the ski slope. He says nice, negative. And then there's no more slope.
On the long, flat part of the course, he said, this is zero fun.
So all you have to write is zero fun. You don't have to write this is. So zero fun and put a 0 on top. So anytime your slope is a horizontal line, or your line is a horizontal line, it is a 0 slope. You would say m equals 0.
And finally, when he went over the vertical cliff and went straight down, he yelled the worst curse word of math and algebra. Undefined!
So undefined is what he was screaming.
The dude was talking really close to the mic.
I know.
I could hear undefined.
His breathing.
The uphill is the slope with a positive number. The downhill is the slope with a negative number. The flat part is the slope of 0. And the straight up and down or vertical part is undefined.
Here's my story. So, dude, official merchandise. We're so mad.
So this is how we can tell what the slopes are. It's positive if it's going from left to right. So you're always reading it from left to right whenever you read a graph. So uphill is positive, downhill is negative. A horizontal line, so this is a horizontal line. it's 0, and then a vertical line is undefined.
So does the undefined mean they can't fix it or like solve it?
So undefined, and you'll see this in your calculator. It's a really good question. So if I am in my calculator and I say it rises 5, but it runs 0, that's like saying 5 divided by 0. What do we know about dividing by 0? You can't do it. So that's why it's undefined. But what if I do this one and say it rises 0 but runs 5? 0 divided by 5 is 0. So you can have 0 on the top of a fraction, but not on the bottom. So anytime you have a 0 on the bottom, it's called undefined. And you'll see that from math courses from now on. So you got to pay attention to that. All right, so x-intercept. So let's talk about what an intercept is. An intercept is where your line crosses something or two things cross each other. So an x-intercept is your point where the line crosses the x-axis. So you have to write it as a point. I can't just say a number is my x-intercept. I have to write it as a coordinate pair, like x, y. And so if it's crossing the x-axis, think about your graph where this is x and this is y. X is your horizontal axis. So where it crosses the x-axis is going to be a point where you have a number for x and a 0 for y because it's not going up or down any. So it's going to have a number for x but a 0 for y. And from now on in math and in algebra, calculus, and all the math courses that you do from now on, you're going to talk about different ways of finding this value, your x-intercept, which is also called, also known as, aka, solution, 0, root, or intercept. So the x-intercept has all these other names. They're aliases. Y-intercept isn't quite like that. It's important, but the x-intercept is something that we are going to be constantly finding. So the y-intercept is the point where the line crosses the y-axis. So on the y-axis, so look at your y-axis, you're not going to go left and right any. You're only going to go up or down. So you're going to have a 0 for the x value and some number for the y value. Which, when we graph this, whenever it's in that y equals mx plus b form, b is your y-intercept. I'm going to abbreviate and just put y-int, intercept. So we could actually write this as 0, comma b. B is wherever it crosses the y-axis. All right, let's open up our foldable. We're going to look at 4 graphs. We're going to find equation, slope, x-intercept, and y-intercept on each one of these, but not in that order, because you really need to know your slope and your y-intercept before you can write your equation. So we are going to look at this graph and find perfect points. So perfect point is where it crosses exactly through that point. So like this would be a perfect point. And this would be a perfect point. That's a point right here, but it's not a perfect point where it's perfect whole numbers that you're going through. So let's go ahead and put points where our perfect points are, where the line goes perfectly through that coordinate of whole numbers. And there's one more right here. So we can see these three. This should look like a pattern, a stair-step pattern. First off, what kind of slope is this? So think back to slope, dude. What kind of slope is it? All right, so we can write that. Puff, puff, positive. He's breathing really hard climbing up that hill. So let's count. So the first thing we're going to do is our slope. So I'm going to put number 1 here. Slope is rise over run. So you always start at the leftmost point and rise and run to the next point. So this is like my starting point. And I can pick any 2 points, but you always want to start at, if you have 2 points, your leftmost point. So I'm going to start right here. I'm going to count rise over run. So make your jumps. You have to show your jumps on here. So it rises 1, runs 3. And your slope should be consistent if this is a straight line, if it's a linear function. So let's do that again. Up 1 over 1, 2, 3. Same thing, right? So we're going to write M equals 1 over 3. I could have gone from this point to this point if I wanted. So let me show you that. I could go from here to here. So I would count rise 2, run 1, 2, 3, 4, 5, 6.
Do you just divide it by
Which
how
is
many
the
numbers?
same thing. Yeah. Same thing.
You divide it by how many numbers you're going to? How many dots?
Yeah, so I'm doing the jumps.
Yeah.
Yeah.
But like, how would you know? I guess you just put it down.
And they just simplify it to the.
Yes.
Yeah, simplify it to your lowest reduced form.
Okay.
So it doesn't matter if you go between your furthest points or your closest points or anything in between, because it'll always reduce to equal that same thing. All right, let's look at the second question, or actually it's the third, but we're going to call this our second. X-intercept. Where does it cross the x-axis? 3. Okay, so I'm going to use my highlighters to distinguish between x-intercept and y-intercept. So my x-intercept is, this coordinate is, you start at the origin, you go right 3, and then you don't go up or down, so it's 0. If you look back at our notes, it was the x-intercept is x value and then a 0. So that's what we did, the x value and a 0. You have to write it as a coordinate pair. Okay, and then our y-intercept, so the next one we're going to find. So how do we write it as a coordinate pair? Yep. And we're also going to write that b equals -1.
Is that just like saying x equals -1?
Well, remember our equation, y equals mx plus b?
Oh.
That's our slope-intercept form. We can plug in our slope and our intercept to write our equation of the line. So this is the fourth step that we're going to do. So y equals mx plus b. So it's y equals, m is 1/3, We keep x and y as part of our variables because this is a 2-variable equation. And then plus b, or I can just do minus 1. You can do plus a -1 or just minus 1. They mean the same thing. We're going to check our work, though, by putting this into the calculator. So get out your calculator. So go to y equals, put in 1/3 x minus 1. Then we hit graph, and then we just make sure that it looks the same. So something I do want y'all to get in the habit of doing is once you graph it, push trace. And then whenever you push trace, it's going to put a point on there. It's going to show you the coordinates to that point. So see how it says 0, -1? We have that point right here. Then you can go left or right to find other points. So I'm going to find my x-intercept by going right and get as close to it as possible. So look at it. So see how it says x is 3.03, repeating, and then y is 0.01. Yours is probably going to be different, and that's okay. It's because my point is not exactly on that x-intercept, but if I were to round, that would still be 3, 0 for our x-intercept. All I hit was trace, and then I arrowed to the right to get to my x-intercept. So if we were to round that, what would that round to? 3, exactly. So just realize it's not going to give you the exact point on there, but it's going to give you the exact coordinates of the point that it has. But you can also go to your table. So second graph for your table and make sure that that 0.30 is on there, which it is. Okay, any questions about the graph or any of those tools?
Wait, how did you do it?
Which
How
part?
did you make it fractional?
Oh, because whenever I put this in, I put it in as a fraction. So if you put it in as 1 divided by 3 like that, it's going to give you decimal. See the difference on that?
Yeah.
It's still going to be the same.
So do we just go down to like how do we do it if we do that?
So what I would do is I would get in the habit of making this a actual fraction by doing the alpha y equals and put that in instead of the 1/3. Just because it's cleaner whenever you look at your table of values. It just looks so much cleaner on there. But if you're going to graph it, you want whole numbers really. So you just go through here and find your whole numbers, which you can 6, 1, 3, 0, 0, -1, -3, -2 in order to graph it.
We're just going to put in a bunch of them.
All right, let's go to the second example. Okay, let's find at least 2 perfect points. Those are where it goes exactly through. What's 1?
0, 3.
Yeah, you can put all of them if you want. So 0, 3, and then
1,
1, 1.
1 at 5, and then 2, -1.
2, -1, yeah.
There's one at 5, -1.
-1, +5, yeah.
-1.
Yeah. So see how it's following the same pattern wherever you put your dots on there? So let's do the slope. So that'll be first thing. So we're going to count. What do you notice about this kind of slope?
It's nice.
Nice negative. So we're going to count rise over run. So what point do we need to start at? It doesn't. Okay, we can start here, and then we're going to count to go to this next one. So it goes down 1, 2. So -2 rise, which actually is a fall, over or run 1. -2 over 1, which just equals -2. So the down is a negative direction. Right is always a positive direction. All right, let's look at number 2. I'm going to use my highlighter again. Find my x-intercept. Okay, where do you think that is? 1.5, 0. And then y-intercept. Is 0, 3. So that means b equals 3.
Is it ever gonna be like really hard decimals?
Yes, it will. So all we're working with right now is halves and wholes. But yes, it will. And then we have to use a formula to find it. Okay, and then our last step is y equals mx plus b. So y equals m is -2x plus b, so plus 3. Check it in your calculator. Make sure it looks the same. Check your x-intercept.
So the y-intercept doesn't matter,
What do you mean?
like in the equation.
Your y-intercept is your b.
x-intercept.
Right. And the x-intercept does not show up in y equals mx plus b. Yep. You're right about that. Okay, so then you can kind of look at it. Looks pretty good. You can hit trace, and it's at 0, 3. And then go down, see if you can get close to the 1.50. So if you look at mine, it's at 1.515. But if I round it, that's 1.5. And then the -0.030303 would round to 0. All right, let's go to the next side. Okay, we need some perfect points.
0, 1.
Mm-hmm.
0.
Yeah, 2, 0.
4, 4.
-2.
Oh, is it
-2.
2.
2. Yep.
-4.
-4.
4.
No. It only went up to 3.
Oh, my bad.
That's okay. And is there one more?
-4.
-4. -1. Yeah.
4. It does say -1.
Okay, 4, -1. There we go. What kind of slope is this? Yep, so nice negative. Let's find our slope first. Rise over run. And it should follow that same path. Down 1 over 2. Down 1 over 2. Down 1 over 2. So our slope is -1/2. The negative does not have to be on top or bottom. It could just be out front, or it could be attached to just the top. But definitely don't put a negative over a negative unless it's a positive slope because they cancel each other out. Our x-intercept, 2, 0. Yep. Then our y-intercept, and so our b value is +1. Then we write our equation, y equals mx plus b. So y equals -1/2x plus b, so +1. Go ahead and check it in the calculator, make sure it looks the same. If you want fractions in your table, you want to use a fraction in your equation whenever you plug it into y equals. If you want decimals, you can put it in as 1/2. Net trace, 0, 1. And if we go down, that would round to 2, 0, which that's what we got for our x-intercept. Okay, last one. Let's find some pretty points, perfect points. -3. -3, -5. What'd you say? 6, 1. Yeah.
3, -1.
3, -1. -6.
-0,
-7. Yep. And 0, -3. Yeah. You can pick any 2 points to go between. Just make sure to go on. If you're using these 2 points, you want to use the one on the left side of it. So let's say I just want to go and find the slope between these 2 points. I'm going to count rise 1, 2 over 1, 2, 3. Oh yeah, it's positive. Puff, puff, positive. So our x-intercept is where it crosses the x-axis. So it's in between those 2 points, exactly in between those points.
You got halfway. So 4.5.
Yeah, it looks like 4.5.
Oh, right there. Oh,
Yeah.
The y is -3.
So then once we get our y-intercept, we can say that b equals -3. And we can write that as an equation. So y equals mx plus b. So y equals 2/3 x minus 3. Check it in your calculator. Make sure it looks the same. And your assignment's going to be a worksheet. All you're doing is finding the slope from the graph and then reducing it if you need to.